All right. So the agenda for today, then, we are going to be talking about colors. There are three basic ways that colors are used, and so we're going to talk about all of those. We will talk about color blindness, and we'll talk about ways to check for color blindness, and then we'll talk about some common problems with color. All right, we will talk about palettes some, but we're not going to really devote a bunch of time there. Okay. So the main learning objectives are to understand different types of color palettes and when you should use one versus another. All right. And by that, I mean mostly just like exploring different palettes and then sort of probing the palette to make sure it's working well for color blindness issues. And that's sort of the second point. And then the last one is quite important too, be able to fluently change the color palette for ggplot, for either the color or the fill. Okay. So before we get too deep, I've already mentioned this, but I want to mention it again because it's a very common problem. When you're working with colors for either fills or colors, right? It's really important to keep straight when you just say color equals or fill equals, and when you need to use scale color or scale fill, right? And it's basically, if you're mapping data to the color, then you're going to put that value in AES, right? Color equals whatever the column name is. And if you're doing that, if you have the variable inside AES, then you're going to need to use scale color or scale fill, whichever one it is, all right? Otherwise, you do not, okay? So I know I already mentioned this, but I'm re-emphasizing it just because, like I said, it's a really common problem where people will say scale color and they'll put some palette and they're like, it's not working, it's not making any difference to my plot. And the problem there is usually because you don't have a variable that you're mapping color to, right? So you have to have inside AES color equals or fill equals and have it mapped to a column in your data set. After that, you can use scale color or scale fill. Otherwise, you're just saying color equals blue or whatever. The other thing that I would say that's really practical advice is just use the work of others to your advantage, all right? Color Brewer is one of the older ones. It's been around for a long time at this point, but it's been very successful in large part because it works well. And when we go there, if we go here, right, this is what it looks like. And you can see there's all of these different palettes, and you can see you can pick the type of palette that you want: sequential, diverging, qualitative. We'll talk about each of these today. And then you can also do things like click colorblind safe, and it will only show the palettes that are colorblind safe. All right. And then you can click on them and you get little previews. You can say how many categories you need, etc. Okay. And then once you get that, then this is the palette right here, red, yellow, blue for this one, right? And then from there, we would just use scale color brewer or scale fill brewer, which I'll show you an example of later today. All right. So again, colors are deceptively complicated because they're so tied to visual perception. And there's people that have done a ton of research on different color usage and how to sort of maximize differences between categories while making sure that they work for a wide group of audience and things like that. So there's a lot of different palettes out there. Some work really well, some don't work very well, but use the work of others as much as possible, okay? All right. I want to give a couple examples of why color choice matters so much, right? So here's an example. This is from our reading where you have this like green and red thing. And it's kind of hard to tell what's going on here, what it even is, right? But if you just use a monochromatic color scheme, you can see very clearly what it is, right? It's like some sand and hills and things. And so the amount of detail that you're able to pick out here with just a monochromatic color scale, gray scale in this case, versus here is huge, right? You can see far more detail in this example than you can here, okay? And that's primarily because of color use, okay? I also wanted to show, this is from RStudio Conf actually 2 years ago, Ray Shader. So some of you may be familiar with this package, but I'm going to show an example from his talk here.
Very outdated.
That basically, in my mind, shows the difference in how much of a difference color can make. Okay, so let me get here.
We can have full control over their appearance. So this is what happens when you plot elevation data with base R using the image function. The code is on the left and the output is on the right. This is Hobart, Tasmania, but looks more like two amoebas dueling it out in pond scum, or as base R calls it, terrain colors. Here, the Hobart object is nothing more than a base R matrix. Here is the ray shader version of that plot using spherical shading. It's a much more naturalistic view of the data. While you lose the direct mapping of color to elevation, you gain a much more human understanding of the landscape's contours. Note how details appeared that weren't apparent in the base R plot, namely the fact that there is a river between these two mountains. Ray shader is built around elevation data, and building a plot works similarly to how you build a plot in ggplot with layers. Here, I've added a water layer simply by calling the detect water and add water functions in Ray shader with the elevation matrix. This overlays a water layer on top of the sphere shade layer. Now, Ray shader's name comes from the fact that it uses ray tracing to shade topographic maps. So much like we added our water layer here, we can add a shadow layer simply by calling the add shadow function with the ray shade function. This traces rays from each point on the elevation matrix, determines if that point is in shadow or light, and shades it appropriately. The add shadow function layers it onto the existing plot, passed in using the pipe operator. We can continue stacking different types of shadows with additional calls to add shadow. Here we add an ambient occlusion.
All right, so I'm going to pause there, but basically we have, and I think he even goes a little further. But basically, well, now he goes to 3D, but let's go back here. So this is a 2D version, right? So you have this version of this map versus this version, right? And there is some fancy things going on here with, you know, trying to get it to shade correctly and whatever. But primarily, that is just a difference in color use, right? Sorry, I'm missing all of my people. Does that make sense? All right. Questions on that at all? The other thing I wanted to mention is I will send out a link about this soon, but I don't know why I lost all of my I lost all of you. I can't see you all anymore. But the newest RStudio Conf video recordings are now out. Okay, so I'll send a link to those, and I would recommend checking them out if you have the time. Specifically, the keynotes. There's 3 keynotes. They're all great. Okay. All right. Let me see if I can get this back. I don't think I'm going to be able to. For some... Oh, there we go. Got it. All right. Okay. So moving on. So there are 3 fundamental uses for color, as I mentioned. One is to distinguish groups from each other. The other is to represent data values. And the third is to highlight specific values. Okay, so we'll go through each of these. First, color as a tool to distinguish. All right. So very often you have some discrete items and there's no intrinsic order. So one is not more than another, right? Like categorical sort of things. So this is when you would want to use a qualitative color scale. This means that there's going to be a finite number of colors. Each color should map to one value, right? And those color values should be chosen to maximize distinctness. Okay, so they should be each color should be as different from the others as possible, while at the same time being equivalent. And this is where I say, like, what I was referencing in part when I was saying color can be deceptively difficult, because what I mean by equivalent is that there shouldn't be one color that sort of stands out from the rest of them, because that would be having one color to distinguish from others, right? And if you have a qualitative color palette, you don't want any one value to stand out from the others. And similarly, there shouldn't be any impression of an order, that one is more than another, okay? And so this is not something that you can just pick some random colors and have those properties, okay? So here's some examples. And for some reason in the published version of this, I was having a difficult time. So I'm showing this from my local. When I was on Chrome anyway, for some reason this wasn't showing up, and I don't know why, because it's just a link to a different image on the web. It's from our book. But regardless, here's 3 examples of qualitative color palettes, okay? The first one is called Okabe Ito. I'll mention this one a few more times because it's a really good palette for color blindness in particular, all right? This is the Dark 2 palette from Brewer. And then this is just the default one that you get with ggplot, okay? So for each of these, you can see that all of those colors are quite different from each other, right? But there's not a real ordering to them, okay? And there's not really one color that sort of sticks out more than the others dramatically anyway. You could make arguments that like this one maybe sticks out a little bit, but it's not dramatic like, whoa, my eyes are drawn there, right? At least that's the intent. Okay, so how do we use these? Let's imagine that we have data that looks like this. Okay, this is population growth data. This is just data from our book. Okay, so we have the region, the state, and then the population in 2010, or 2000 and 2010, and then the population growth. All right, so we might have a plot that looks like this. Okay, this is the proportion that the state grew in population. So we have population growth. I've styled my code a little bit funky here just to get it to fit on the slide, but you get the idea. Population growth on the x-axis, state on the y-axis, and then we use geom call. Okay, and then they're ordered. It's already factor ordered according to the proportion. Alternatively, we could fill by region, right? And that gives us a little bit more information about this plot fairly quickly. Specifically, you can see that almost all of the population growth has occurred in the west and the south, right? The northeast has by far the lowest population growth across the country. And you can pick that out really quickly by just using, by just filling these bars by the region. And so all we're going to do here, right, is just say AES fill equals region. This is a problem with the default color palette. So here's that same plot that we just looked at according to 3 different kinds of color blindness and a desaturated version. So this is if you're printing it out in black and white. And really, it's not horrifically awful for these 3, especially this one I think actually works okay. These 2 are less than ideal, but they're not horrifically awful, right? You can still distinguish all the groups. But for the grayscale, it's really bad. You can't make it out at all, right? So this is problematic, and this is okay, but it probably could be better, right? Alternatively, we could use the Viridis palette. Okay, these are very often used with maps. That's probably their most common use case, but they can be used for anything. So there's scale fill Viridis _D, meaning discrete, and underscore C meaning continuous. Okay, so here we have a discrete scale, so we're filling by region, and so I just say plus scale fill Viridis, and now I get this instead. And when I reproduce it there, you can see it looks like this. So this works pretty good for all of these. I would argue they work at least as well as the previous palette, but it works much better now for the black and white version, okay, if you were just printing it in black and white. So that's one option, but you might say, well, I don't really like the way that looks, though. It looks kind of funky, okay? Well, here's another option then. This is the Okabe Ito Palette, and this here links to a paper about this palette. Basically, these people did an entire study just to come up with a new palette that works well for color blindness. Okay, so this palette is available through the Colorblinder package, which I'll have you installing later. And I'll show you the code to do that because it's not super easy. It's not as easy as others. But then you're just going to say plus scale fill Okabe Ito. Okay, and then you get these colors instead. And we can reproduce it here. It still doesn't work as well for the desaturated version as the Viridis palette. So if you're focused more on it working well in a black and white and color version, then this probably isn't the one that you want to pick. But if you know it's going to be in color and you just want it to work really well for color blindness, you can see across these three, they're all still very distinctive, right? More distinctive than the Viridis palette. Okay, but if you're going black and white, again, it doesn't work as well as the Viridis one did. Okay, so the Viridis one I've used this palette when I submit figures for publication, because they often want them in black and white, and I just say no. You just print this in black and white and it will be fine. And then on the online version, they can print the color one, hopefully. And that's worked sometimes, not all the time. All right. But again, if you know it's going to be in color, this one's probably better. So how am I checking for color blindness? This is one of the things I'm going to ask you to do during the lab. It's part of the Colorblinder package. Okay, so this is a link to the package, but the thing that is a little bit difficult about installing it, and it's not horrible, but it depends on the development version of the color space package, and that is not available on GitHub, so you have to download it from RForge like this. Okay, it also depends on Cowplot, which is probably a useful package anyway that you should probably just have anyway. All right, Cowplot is also by the same person. Well, it's Klaus Wilke, the same person who does our book. Okay, did both of these. So you're just going to install Cowplot the same way we normally do. I have DevTools in here, but it'd probably be remotes. And then install.packages color space, and then you just put the repo there as RForge. Okay, and then from there you can install Colorblinder from GitHub. Okay, makes sense. And I'm pretty sure this is only available through GitHub because of these dependencies, and color space this version is still not on CRAN. I don't know when it will be because it's been years now, so probably never. All right, then after you do this, all you have to do is you have your plot and you save it in an object. Okay, I like to add theme void to it. You don't have to do that, but I like to do that because that just takes away all of the labels and all the everything. And then all you're left with is the actual plot itself, which is what you're trying to focus on. And then you just say Colorblinder CVD grid, and then pass your ggplot object, and you get this 2x2 grid of the 3 color blindness plus the desaturated version. Okay, so it's pretty straightforward to test for color blindness, and it's really useful, right? Because then you can just kind of create the plot how you want it to be, how you like it to look, and then you can check it for color blindness. You probably don't want to go too far with one color palette before you check it for color blindness to make sure it's working and that you're happy with the end result. But I would encourage you to pretty much always use this when you're creating a plot that's going to be viewed by a lot of people. Okay? Any questions on any of that? All right. So let's move on to colors for continuous values. So if you have a continuous scale, then you want exactly the opposite of what I said before. You want an ordering to the colors, okay? And one of the things that's important is that your visual perception of that color, the amount that it changes, should correspond to the data, right? So the amount that this blue changes to get from here to there, let's say it's 5 points on the scale, right? Another 5 points should get me a similar change in that color. And another 5 points should get me a similar change again. Okay, so the way that the color changes should map directly to your data, right? Again, this is where it's more complicated, I think, than it's deceptively complicated, right? Because you want it to have this ordering that works with your data and that corresponds with your data. Okay, so there are lots of sequential color scales. Very common is to just take a single color and then map it to the data that way, right? So either increasing the saturation or decreasing the saturation of the color. There are, though, also multi-color sequential scales. And so Viridis is one of those. There's a few others. But these tend to map to things that are in nature. So like we think of like blue and red, right? That's a very common multi-hue sequential scale, because blue is like cold and red is hot, right? And so we have the values sort of ranging in between those. So which values are larger or smaller? So again, the idea is that you should be able to look at the color, look at two colors, and figure out which one is more than the other, right? And ideally, if, like, let's say you're looking at three colors, you should be able to say, okay, these two colors are further apart than these two colors. These two are close, these two are really far away, right? And so the scale has to be perceptually uniform across the entire range. So I've already said most of this stuff. Okay, so some common uses for sequential palettes. Heat maps. Okay, we've talked about heat maps a little bit at this point. We're going to talk about them a little bit more. Okay, so here I am going to show a super simple heat map because I'm just trying to show the colors. But actually, this is probably better to do with a bigger heat map, so I probably should have done more because I was just reviewing them this morning and I was like, I wish I had more categories in there, but I don't. So basically what we're doing here is I'm taking the diamonds data set from ggplot. I'm just selecting these 4 variables, okay? Table, price, depth, caret. And then I'm using this correlate function from the core package. And then that's going to basically give me a correlation matrix for those 4 variables. And then I'm going to pivot longer and factory order so that it ends up looking like this. So the row name is a variable, and the name is the other variable, and then the value is what they correlate at. Okay, and when it's the same variable, the value is just going to be NA. Okay, because it's 1.0, obviously. Okay, so we can create a basic heat map with this, like this, right? HM heat map, that's what I called that thing back there, right? Put name on the x-axis, row name on the y-axis, and then we say geom tile, and then AES fill equals value. Okay, so again, if we go back here, here's our value. The value is the correlation. So we're going to fill by the value. And then I mentioned this before, but for heat maps, I generally like to apply chord fixed so that we have squares rather than rectangles. Okay, so we get a heat map that looks like this, where this is a very low correlation and this is a very high correlation, and these are somewhere in between. All right, so this is just the default with ggplot. I can change that default pretty easily, right? So scale fill distiller is one option, and there's a bunch of different palettes. This is one that ships with ggplot, right? So there's a bunch of different palettes like blues and reds, and I think there's greens, and a few others, all right? So in this case, we're saying palette equals blue, where white is the highest, okay? And this dark blue is the lowest, all right? In this case, I think you could argue that that makes sense. You could also argue that that looks backwards, right? And that the dark blue should be the highest and the white should be the lowest. I think specifically you could do that if you wanted to say all of these NA values should be white, right? And then you're just looking at darker colors of blue, basically. So if you wanted to do that, you'd have to look at the help documentation. I don't remember if I show an example of this or not, but they all have, every palette, every sequential palette has a direction argument. So it's either going to be like direction equals -1 to go in the reverse order or 1 to go in the right order. Or you can say like reverse might be the argument, reverse equals true or reverse equals false to reverse the scale, all right? So if you think that this looks backwards for your specific plot, you can just reverse it, okay? You should be able to do that for all sequential palettes. You also might want to change the NA value, okay? So over here, you can see it's this dark gray. Maybe I want to try to neutralize that a little bit more as much as possible. So here I've said NA.value equals, and I just kind of found a value that looked decent to me, okay? And so it's just a little bit less gray, a little green actually. And then that's maybe looking a little better. Okay, this is important mostly because there's very often times where you're trying to say there's a 0 value and NA values are the same as a 0 value. So I want that NA value to be the same as a 0 color. Whatever the 0 color is, that's what I want my NA value to be, okay? Otherwise, if you don't have something like that, where it's like the NA value doesn't actually represent any value on the scale, it's just missing, then you're probably going to want to play around with that, because that can very easily introduce visual artifacts to your plot, right? Because it's going to look like you mostly have one color and then you have these missing values, and those missing values might end up looking like they mean something when they actually don't, okay? So I don't really have any great advice for you on how to make that as neutral as possible. It's mostly just something you got to kind of play around with, but I do want to make sure that you are attentive to it and that you're aware of it, okay? Because very often you end up in situations where you have more missing data than you'd like, but you still want to show the thing. So again, if you can make NA map to a value that is meaningful, then just assign the NA value to that color. Otherwise, you just got to try to make it as neutral as possible. And then just one more example. So notice here I have scale fill Viridis _C this time instead of _D. And so we get this bright yellow where the correlation is high. Oh, and then this is changing the option. So Viridis has, the Viridis palette has 4 different options. Viridis is the default, but then there's magma, infernal, and plasma. So they have like really strong names. But this is an example of the magma palette, which I tend to like more, just because the black is like black, and then this is like really bright, right? So these are really contrasty. Another really common use of sequential palettes are Choropleths, okay? And on some of your final project proposals, I mentioned that you might want to try out a Choropleth. We will be talking about how to produce these later in the term when we get to geographic data. But this is an example of Lane County, and we're looking at the percentage of people identifying as white. So it's, you know, almost everybody. And when we get to Eugene, it's a little bit darker there, so a little bit less, but pretty darn white county. We can also change the palette to like a heat palette. So this is, I think it's just scale fill distiller heat, okay? And you can see, get a pretty different view of it. Similar, but not quite the same, right? Yeah, so there you go, scale fill, continuous, sequential. And there's scale fill and scale color, and then whether it's continuous or discrete, and then heat. And there are other options there too. There's the Viridis version of it, right? And then you could try others as well. So different palettes will give you slightly different looks at the same thing, and then you kind of have to just decide how you want to present the information, okay? But again, even with this, where you have a map now, you could still reproduce this according to the different kinds of color blindness, right? You could still get that 2x2 grid of the map. It might take a little bit to produce because it's going to have to produce the map 4 times. And maps tend to take a little bit longer to render than typical plots, but you could definitely do it. All right. Another really common sequential palette is a diverging palette, okay? Diverging palettes are really nice when there is a logical center point, okay? So that's basically what it is. A diverging palette is still for continuous data, and it's still sequential, but it has a balancing point, like a middle point that is like, okay, this is 0, and then these are negative, and these are positive, or whatever, right? So in a diverging palette, you're always going to have this point where you have like some sort of neutral color, and then it's going to get more red in one direction and more blue in the other direction, or whatever, okay, whatever the palette is. So that can be really, really helpful for a whole bunch of different situations. So for example, I produced a map not too long ago where we were looking at geographic variation in average achievement differences at the school between groups of students, right? And so we used a diverging color palette there where like a white color there was no difference between these groups. And then, you know, like a green color is a difference in one direction, and a red color was a difference in a different direction, or maybe it's blue or whatever, I can't remember. But the nice thing about that too is that then the map color was white. So those ones where there was no difference, they sort of faded into the background, right? You could still see them, but it kind of faded into the background. And then the more the school had big achievement differences between groups, the more those schools like popped out on the map, right? So here's another example, okay? This is the entire state of Oregon, and we're looking at the percentage of people identifying as white again, but this time we're using a diverging color palette where we're centering it on 50%, right? So this is like brown and green. If it's more green than brown, that means there's more people identifying as white. If it's more brown, there's more people identifying as not white, right? So not surprisingly, Oregon is a big green state. So this isn't super interesting. So let's look at a different state. All right, now we're looking at California, and you can see, right, that in the southern part of the state, for the most part, less than 50% of people identify as white, right? And then as you move north towards Oregon, you start to get more green, right? And so this is a really nice way of showing, like, for example, right here, this is a county that is probably about 50-50, right? And so you can see very quickly if the county is predominantly white or predominantly non-white, and the degree to which that is the case. Make sense? Questions on that? Okay, so we've covered 2 big topics now. Now we're moving on to another one, which is using color as a tool to highlight specific values. All right. So this is an example of a like canonical scatter plot in R, basically. Miles per gallon, highway miles per gallon predicted by engine displacement, basically, right? With ggplot. So the MPG data set here, right? Let's say that we wanted to highlight specific cars in this data set. Well, this is one way we could do it, okay? Here, we're saying, okay, we're going to highlight all the cars that are compact, all the compact cars, okay? And the easiest way to do this, in my opinion, is to just start by producing the exact same plot that we just did, right? But changing the colors of each of those points to a sort of color that's going to fade into the background. So I use gray 80, gray 90 would work too, right? And those first two lines are just this, right? It's just producing a scatter plot exactly like this, but they are, all those points are this light gray color, okay? Then I'm adding an additional line where I'm calling geom_point again, but this time I'm saying for the data source, filter the MPG data set where class equals compact, okay? And then I'm going to say for those points, color them this way. So what we have here is these, like all of these red points, right, are points where they have a gray point underneath it, actually, and we've just plotted right over that point with this gray, or with this red color, okay? And so now we have this plot where all the compact cars are highlighted and they pop out really immediately, right? So this is a good start. We would not be finished here though, right? If this was our plot and we wanted to highlight these specific points, we would want to use our title or something to call out these points, right? Otherwise it's like, well, what are those points? What does it mean? There's no legend that shows what those points are. We could make it with a legend if we wanted to, and I can show you how to do that in a minute. But we would need something else here to sort of call out those points, but this is a good way to do it. Similarly, let's say we wanted to highlight all the manual transmission cars. Well, now I would just say, okay, string detect from stringer package, where transmission has manual, okay? And that's going to give me a bunch of trues and falses. So I'm going to filter MPG where this is true, okay? Same color, and now we end up with the same thing. Does that make sense? So I'm using one layer to plot all the data, and then I'm plotting over that again on a second layer where I'm only including just those points, okay? All right, I'm looking at Joe's question. Do you want to just ask your question, Joe?
Sure, you're on a roll. I'm just wondering, are they actually layers, or are they like, is it a transparent layer or opaque that just goes down over the top of it?
Yeah, it is. They are literally layers. And so if you flipped these things, if you had this geom_point layer and then this geom_point layer, it wouldn't work. You would end up with all gray because you have your red on the first layer and they'd be plotted over.
Okay, it's like a solid, I'm painting over it.
Yes.
Not with watercolors.
Correct. And so if you want to have that though, where you're painted like over it and you can still see what's underneath it, then you just want to add some transparency to one of the layers.
But that would, if there was some transparency to it, you would see what's underneath.
Yep.
Okay.
Yep.
Cool.
Exactly. And so for a few of you too, for the first lab, you might have seen I flipped the order of some of your layers because you had, for example, like the area and then you had a line underneath the area, so it kind of got cut off or something like that, right? And so the order that you put these layers is important because they are being plotted literally on top of each other. All right, let's go back to our states plot for a minute, okay? So let's pretend that we wanted to highlight Oregon and Washington, okay? So we have our population growth. We're putting population growth on the x-axis, state on the y-axis, using geom_call, filling by region. I'm saying alpha equals 0.9, so I'm saying 90% opacity, right? So 10% transparent. And then geom_call, now I'm adding another layer on top of those geom_call where I'm saying filter the population growth data set where the state is Oregon or the state is Washington. All right. And then I'm filling with that red color again. And now I'm also saying scale fill Okabe Ito. All right. But notice I only have this AES fill here, right? So this column is going to be changed by the Okabe Ito one, not this one. Does that make sense? I have AES fill equals region here. So that's what's going to be changed by Okabe Ito, not this one, right? This one is going to be completely unaffected by that line. Does that make sense?
Is it because you've specified fill, or is it because of it being placed within the aesthetic?
It's so because I have fill being mapped to a column in my data set, which means I have to use AES, then that's what this is changing, right? Whenever we use scale fill or scale color, whatever, it's going to modify the variable that we put in our aesthetic. Okay, so then I end up with something that looks like this. So this is similar to what we had before, but now we just have, we can very quickly, Washington and Oregon sort of pop out. Okay, so that's cool. What if we wanted to do more though? All right, so let's say now I want not just the bars, but I want actually these labels over here to pop out also. Okay, I can do this like this, right? First, I get just the unique states that are in my data set. Then I'm creating a vector of colors, okay? And I'm saying if states, this thing right here that I just created, which is just the unique states in the data set, right? I'm saying if that equals Oregon or it equals Washington, then give me this color. Otherwise, give me gray 30. Okay? And now, if you just look at this, right? Over, if I can get back over there. There. Label color, this thing I'm creating right here, just looks like this. It's a whole bunch of gray 30s. And then we have two where we have this color instead of gray 30. And those are the two places where the state is Oregon or Washington. Okay? We can do the same thing with the label face. So for Oregon and Washington, I'm saying it's bold if it's Oregon or Washington. Otherwise, it's plain. Okay, and again, if you look at the label face, obviously it prints off the slides, but it's just plain, 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 and then it'll say bold once it gets to Oregon or Washington. Then we can modify our theme to have these elements. Okay, so we say axis.text.y, and this theme stuff I have finally, after years, started to build some fluency with it, but I don't expect that any of you by the end of the term even will really have fluency with the theming stuff. It's, for whatever reason, it's just really hard to remember what it all is. So you probably have to look this up every time. I did for a long, long time. But so don't feel bad if that is the case at all. But you're going to want to modify your y-axis, right? So axis.text.y, not .x, and not axis.text, because that would do the x and y. So axis.text.y, and then you're going to say element text, because that's the thing you want to modify. And then you're just going to pass these two vectors. So color equals label color, and face equals label face. Okay? And then we get something that looks like this. All right? So Washington and Oregon pop out this way now too. Even better, these values right here they don't really contrast super well with this red. The red still pops out, but we might want to sort of de-emphasize the rest of the colors. So we could do something like this. All right, and this is tricky. This is straight from the book. I tend to have a hard time with this kind of thing, but it's something you just have to kind of mess around with. But basically, we're taking the Okabe Ito palette, and he's switched the order. So this is not my code, it's his code. He's switched the order of them, and then we're just going to lighten and desaturate those first four colors, right? Or actually, Yeah. So we're going to lighten them by 0.4 and then desaturate by 0.8. Okay. And then we're going to darken these last 3 colors by 0.3. Okay. And then that ends up with a palette that looks like this. Okay. These ones I think are probably meant for something different. These first 4 are all lightened and desaturated. Okay. And then we can say, okay, scale fill manual now instead of scale fill Okabe Ito. And for the values, use that accent Okabe Ito palette that we just created here. Accent Okabe Ito. All right. And then I'm keeping everything else the same. So now we end up with something that looks like this. All right. So now we're really emphasizing Washington and Oregon, but you can pretty much get the rest of the plot if you're still interested in it. Even better, and now we're getting sort of to almost a final plot. I would use this GG text package, which again is from Klaus Wilke. He's super good. But then this scale X continuous expand equals 0, 0. This is because we always with bar charts have this giant space here, and it drives me crazy, right? So that's what this fixes. And then this part is, you can see the documentation for it. This is not that big of a deal. I'm not going to talk about it too much, but basically we're using HTML code with some markdown code to change the color in the subtitle. All right, and then you have to use this plot subtitle element markdown, and you end up with something that looks like this. Okay, so now notice these have been shoved over, and then population growth by region, and we say the Northwest is where it's at, right? So it's very clear that the Northwest is these 2 states. Okay, I would still argue there's maybe a few things that you could do from here, but we're getting pretty darn close to like a final product at this point. Questions on that?
Is there any value from your experience of introducing things like pattern into it? I'm just looking at like you lose a little bit of knowing that those 2 states, we know they're in the West, but is there value of saying, well, I'm going to keep that same color, but I'm going to make those little X's or something, or is that a whole different lecture?
Yeah, so you're saying basically fill with a color and a pattern, maybe?
Yeah, I mean, if you kept the color of the West, you know, so you don't lose that information, but you gain it. Like if you're trying to highlight those, you know, there's polka dots or whatever.
Yeah, so generally adding patterns is not real straightforward with ggplot. It's just not something that has ever really been incorporated well. There are a few packages that will do that for you external to ggplot, but I've never really played around with them much. If I were to do that, if I wanted to say, here's 2 states that I'm highlighting, but I want to make sure that I still keep that same color that shows that they're the West, I would probably do that with one of 2 methods. One, I would probably start out by trying just to change the outline of those bars. So changing the color instead of the fill, and just maybe making like a big thick black line around each of them, or a big thick red line around each of them, whatever. That might work. Probably even better though would be to actually add some text annotations, right? So you'd have something right here. So I would get rid of a lot of these lines here that are not super helpful, and then say like Northwest, and then have arrows that point to these 2 states or something like that. Make sense?
Hey, Daniel,
Yeah.
can you feed a vector into alpha values? Because I feel like that would be a way easier way to do almost, I mean, it wouldn't be exactly this, but like you get basically the same thing with way less code, right?
Yeah, if you just fed it like, well, so one thing you can do with alpha for sure is you can map alpha to a variable. So you could do that. The problem is then you would end up with different alpha values for each of these regions. So, but yes.
Well, I just meant on the 2 we highlighted, and just have those 2 being 1 and the other ones all equally being like 0.5.
Yeah, you could do that. And the way I would probably do that is similar to what I just did with having 2 layers, but just having one data set where, or you could have just a column that you're saying is alpha, and where it's like, you know, it could just be logical true and false, and it would be Northwest. Is it in the Northwest or is it not? And then you could map that to alpha.
Okay, Cool. Yeah, I think this looks so much prettier, but it's like so much code. I would probably never think to go down this path.
Yeah, and I mean, that's part of what this course is about, is getting you to think to go down that path. And we'll continue to work with plots like this, where you start out with something and then you just keep modifying it and modifying it. Because, you know, I think I mentioned at the start, but like a huge part of this course is not just building plots for exploratory purposes, but for communication and for communicating them with other audiences. And when you get to that point, you really are going to want to spend a good amount of time with a plot, with building up a plot and trying out different things and the code for the specific plot. I mean, I can show you some of the code in my plots that I've put in publication are like, you know, 40 lines of code for one plot. And so, yeah, it takes a while. Okay, last example for today is another highlighting example. Okay, so this is from the LME4 package. We're going to look at the sleep study data. Actually, before I do this, though, I did want to mention one thing, because I don't know why I just thought of it, maybe with your comment, Chris. But in the lab, the second question asks you to reproduce that plot from 538. And I thought I mentioned, but I just want to make sure that I'm clear here, that I want you to basically reproduce the plot, all right? It does not have to be exactly the same. So if the colors are not quite the same, that's fine. If the fonts are not the same, that's fine. If the theme is not quite the same, that's fine. But I want you to basically reproduce it, okay? One of the things that I would like you to do is make sure that the ordering, stacking of those different like area things are the same. You should be able to do that, but don't worry about matching every single thing exactly, okay? All right, just make sure. All right, back to what we were doing. Last example, so sleep study. So it looks like this. This is like a weird study, but it's basically the number of days that people are going without sleep, which seems like impossible. But and then their reaction time to different tasks. Okay, and then these are subjects. All right, so this is what it looks like. So we have sleep study data, right? Putting days on the x-axis, their reaction time on the y-axis, and then we're putting the group is equal to the subject. So a different line for every subject of the study, okay? And we're saying plus geom line, and it looks like this. We might want to highlight specific participants. So that's where, like, if you want to highlight participants that meet some criteria, that's where this GG highlight package can come in really, really handy, okay? So I'm going to say GG highlight. So I'm just loading this package first. Then I have the exact same code here, but then I'm adding one additional line where I'm saying GG highlight where the max reaction is greater than 400. Okay, so here's 400, right? And any participant that has a max reaction time of 400, we're going to highlight their entire line, and it's going to gray out everybody else's. Okay, so very helpfully here too, it also gives me a little ID variable for each of them. So this is participant 308, 337, and 332. Okay, this is using color to highlight, but it's not like it's just grayscale, right? Black versus gray. Okay. We could also change the color by now just adding plus scale color Okabe Ito. And this is kind of interesting because I've also changed now to say color equals subject here instead of group equals subject. But what we're doing here is the same, basically. But had I not included this line, then every line would be its own color. But because we're using GG highlight, it's still going to gray out every group that doesn't have that condition, that doesn't meet that condition, where the max reaction time is greater than 400. Okay, and then it's only going to use our color scale on those groups. Okay, so this is a pretty nice plot. if you're trying to communicate, these are the people that had a really high reaction time at some point during the study, that you can produce quite quickly, right? You can also use facet wrap. So instead of saying, so I still have color equals subject here, but I'm saying facet wrap by subject, right? And then GG highlight. And now I'm going to get different facets for each subject where we have the subject highlighted in each facet, and we've got everybody else in the background. So again, this is different than what you would get if you just said facet wrap by subject, because then you'd get a different plot for every single subject. And that's not what this is trying to do for you. It's trying to show you a subject relative to everybody else, right? So when you say facet wrap by subject, if you're using GG highlight here, it's going to create a different facet for every subject that meets that criteria, and then it's going to show everybody else in the background. Okay, so this is, again, I would argue, a pretty nice plot that is produced relatively quickly. But GG highlight can be kind of difficult to work with because of things like this, right? Where it sort of fundamentally changes the way that ggplot works, right? It's producing things that are very different than what you would get if you weren't using ggplot. So you have to be kind of careful about it and make sure you're getting what you want. And in some cases, as I sort of showed before, I think it's easier actually to not use GG highlight and to just do it manually. But in some cases, it can be super nice. All right. All right. Last little bit. A few other things to consider. We got about 10 minutes left here. Double encodings. Okay. So I've talked quite a bit at this point about color blindness and how it can be a challenge, right? So one of the ways that you can get around that is by using double encodings. Okay. So here's a plot. This is from the Penguins data set. But this plot is a little bit less than ideal. Even though I've used a palette that is good for color blindness, if we look at it like this, it can still be, especially in this one, fairly difficult to compare these two different islands, right? Which points came from which island, all right? So instead, we can just use double encodings. So we're using color for each island, but we're also using shape for each island, all right? And so the way we would do this is when we're building up a plot, we would say within AES, right? We would say color equals island, but then we'd say comma, shape equals island, right? And then we'd get different shapes for every island in addition to different colors for every island. I think this plot is not quite as pretty, as visually appealing, but it works better, right? And these points are too large now for these plots, but you get the basic idea. It's much easier to identify the islands regardless of whether the color is working for you or not. Okay, so that's just something to consider. It can help the way that your plot is perceived, specifically for people who have color blindness. If you have like a lot of overlapping points, then this is going to be good. And if you're not certain that your scale is going to work for everybody with different color blindness, then this is a good idea. All right, some common problems. This is probably the most common problem, and I see this really, really regularly. All right, if you get more than 5-ish categories on a qualitative scale, then it's going to be really difficult to track. So this is like, again, super common. You have a plot of some points, and you're mapping color to state, right? And there's just way too many categories. I can't look at this color and tell you what state that is. If I really focus, I can say it's probably Rhode Island, would be my guess. And but there's this blue and this blue. And so if I look over there, I'm not sure. I can't tell you which one they are, right? If you really concentrate, you can probably have a pretty good guess on most of them, but almost all of them, it's going to be between two states where you're like, oh, it's probably this one or this one, right? So that's very much less than ideal. You can use labels instead, and if you were able to really expand this plot out so that you had a lot of space for it, this might work really well. In this case, it's jammed in there way too much. So it still is hard to track. But now we've at least been able to call out each of them. And notice the one I thought right here, I thought that was Rhode Island maybe, and it is not. So there you go. All right. But another thing that you can do is you can use labeling to highlight, basically, rather than colors. So here I've just picked some random states, and then I'm saying these are the states that I want to label. And then I'm creating a subset of my data that has only those rows, right? So I'm subsetting my data, my population growth data, where I'm saying where state is in toLabel, okay? toLabel being this vector of states I want to label. Right? Then we use ggRepel, which I think is quite a nice package. And then we say this part, right, is just what we've done before, but I'm using gray 70. And then geom text repel, where I'm saying AES label equals state. And now it's going to label each of these states. I'm going to only use that subset of states. And then this minimum segment length, that's just going to always include that little line to the point. So you can see exactly which one it is. So like Wisconsin here is clearly this point and not like one of these other ones. All right. This is just a random thing. And, you know, there's still some problems with this, but we're getting there, right? You can see sort of the direction we're heading here. Another thing to avoid, and this makes people sad sometimes, but is the rainbow palette, okay? It looks pretty in some ways, and like there might be specific use cases where you'd want to use this, like maybe you're doing some LGBTQ plot, then maybe the rainbow palette is going to be perfect in that case, right? But for general purpose plots, it doesn't work particularly well. So I've linked to an article here for a few reasons to avoid using it. But generally, that's going to be something you want to avoid also. All right, so last sort of few notes and advice. Do some research, find what you like and what tends to work well, okay? So those things don't have to be mutually exclusive. There's tons of palettes out there. Some have zero research on them. You can do your own research on them by just doing that CVD grid, right? To look at how they might be perceived by people with color blindness. The other thing you can do is just ask other people what they think. So create a plot or a couple of different plots and just go ask your colleagues, ask your friends, ask people who, like, if depending on what your purpose is, you know, if it's to communicate with other people in your field, then ask some other people in your field. If it's to communicate with a broader audience, then ask, you know, your significant other or your friend or whatever. Ask some people that are maybe not in your field what they think about it. All right, so do check for color blindness. I would argue that you should just do that generally anyway. Color Brewer 2, I already talked about that a little bit, but I think that's a good one. So Scale Color Brewer and Scale Fill Brewer, those ship with ggplot also, so you don't have to worry about installing any extra packages or anything. You just do it like this. So this is the same plot we've been working with a lot of today. Just say Scale Fill Brewer and then specify the palette that you want. So again, you can find that palette through the name in that link I showed earlier, which is also linked here, right? And then you just put that name in there. So this is set 2. And I think this looks pretty nice personally, right? And if you check that with color blindness, I believe this one works pretty well also. I don't have that slide in here, but it looks pretty nice, I think. Last thing I kind of wanted to mention is there is this Palleteer package. This is by a guy named Emil Hevidelt. I don't know how to say his last name. But it's nice because it's just sort of like a conglomeration of all of the palettes that are out there. So literally the purpose is to say there's been 18 bazillion people that have created palettes. So here's all the palettes that are included currently. And so he links to all of those so you can go and, you know, click on one of them. This is soil palettes, and let's look at the actual palettes here. And then it gives you basically just a way to use ggplot code essentially for any of these. So because some of them are built directly on top of ggplot and others are not. So this gives you the ability to use ggplot with all of them. So scale, color, Palleteer, D, and then you just put the palette in there. Okay, there's a lot of fun ones in here. In fact, Sienna, who many of you probably know, Bedford, let's see if I can find it real quick. She just put one out on GitHub that is the, oh shoot, I don't think this is gonna work. Yeah, cool. So let's see, I'll go here. Yeah, the Inauguration color palette. So all of the different colors from women from the Inauguration. And then she was asked to add Bernie too. So I think she added Bernie's mittens too. So, so it's just kind of a fun thing. And this one hasn't been incorporated into Palleteer yet, but my guess is it will be. Okay. So that's like a real quick overview of colors. Like I said, the main thing, if there's one takeaway that you should have from this, it would be, at least from my perspective, it would be colors are really, really useful, but they are deceptively complicated. Okay, so use things that other people have created in the past and be careful with them and be attentive to color blindness issues and things like that. Okay. So we will have lab 3 on Wednesday. This will actually be our last lab, even though we're about halfway through the term. We have one more homework as well. And I am not 100% decided yet, but I'm pretty sure I'm going to make that one a group project as well. Again, all of them you can do as a group or you can do individually, but I think I'm going to require homework 2 to be a group project again, because I want you to continue to practice with Git and GitHub and branching and issues and all of that sort of stuff. So I'm pretty sure I'm going to do that. But this will be our final lab, and then we'll have one more homework, and the rest of the time is basically for you to do, to work on your final project, okay? So I think I got all of you feedback on your final project proposals if you've submitted them. If you haven't, please try to submit them soon, and then I'll get you feedback so you can start to move forward with that, okay? Any questions? Anything anybody wants to mention before we go? All right.